Welcome to Rex. In this video, we'll be learning about how to run a one-way analysis of variance, also known as ANOVA, using a k-independent sample f-test in Rex. The ANOVA test helps us to compare the means of 3 or more independent groups. Specifically, we will be testing if different levels of a factor have a significant effect on a variable of interest. The means of each group will be compared through the analysis of variance within and between groups. Note that in order to run this test, your data must meet the assumptions of independence, normality, and homogeneity of variance. Let's first take a look at our data. In this dataset, the vitamin D level was measured for 30 patients who were grouped based on their outdoor activity level. Here, patients in Group A were active more than 4 times per week. Those in Group B were active 1 to 4 times per week. And finally, those in Group C were active less than 1 time per week. Let's say we want to see if the mean vitamin D level of these 3 groups are different. In order to run our analysis, we select our data, and we go to Compare Groups, Compare Means, and K-independent sample f-test, or one-way ANOVA. We'll first be using this variable tab to define our dependent variables as well as our independent variables, which are called factors. As we can see, the headings in the first row of the Excel sheet are displayed under all variables. We can use the arrow buttons to add or remove variables from each option. Let's first select the variable of interest, vitamin D, as the dependent variable. Next, we'll be selecting group as our factor. We will click Main Effect to include the factor as a main effect in the model. Next, we go to the Analysis tab to select the sum of squares calculation method and to decide whether or not to perform post hoc testing. First, we will select the sum of squares method to calculate the F statistic. We will select Type 2 in order to test individual main effects in the model while only considering main effects and not interactions. Next, we will check this box to perform post hoc testing. This enables the bottom portion here. We want to assume that variances are equal for each group, and specifically, we want to perform a Fisher's least significant difference test, labeled LSD. Lastly, for our post hoc test, we will set the confidence level to 0.95. Finally, we go to the Output tab. In this tab, we can select the graphs to output as well as the statistics to output in the Excel sheet. Today we will output a box plot for our data. Once we are done setting up our analysis, we click OK. Once the analysis is complete, a window pops up with the results. Let's take a look at our results. The analysis description displays our test parameters, and the descriptive statistics displays the number of valid samples, mean, and standard deviation for each group. Rex first verifies that the data meets the required assumptions to run the analysis. First, we had to assume that the dependent variable was approximately normally distributed for each group. Here, the Shapiro-Wilk test is used to test for this assumption of normality. In this test, we reject the null hypothesis of normality when the p-value is less than or equal to 0.05. This indicates that the data is not normally distributed. However, for our data, we can see that the p-value is greater than 0.05. This result indicates that our variable, vitamin D, is normally distributed. A QQ plot, which shows the distribution of the data against the expected normal distribution, can also be used to visually check for normality. As we can see, the data forms a pretty straight line, which tells us that the variable is approximately normally distributed. Next, we also had to assume that the variances are approximately equal across groups. The Levene's test was used to test for this assumption of homogeneity of variance between groups. In this test, we reject the null hypothesis of homogeneity when the p-value is less than or equal to 0.05. This indicates that the variances are not equal across groups. However, for our data, we see that the p-value was greater than 0.05, which indicates that the variances are approximately equal across groups. Given that the required assumptions are met, post-hoc analysis is used to determine whether the difference in mean values between groups is statistically significant. Notice how the p-values are less than 0.05 for the differences between groups A and C, and between groups B and C. These indicate that the differences in mean vitamin D level are statistically significant between these groups. On the other hand, notice how the p-values are greater than 0.05 for the difference between groups A and B. This indicates that the difference in mean vitamin D level was not statistically significant between these groups. Next, let's look at our graphs. Here we see a box plot that is color-coded for each group, which helps us compare the distribution of each group. Overall, as we have seen in this video, the ANOVA test helps us compare groups and test if different levels of a factor have a significant effect on our variable of interest. Thank you for watching today's video in Statistical Analysis in Rex Pro. Don't forget to like and subscribe to RexSoft's YouTube channel for more informational videos on statistics, data, and how to use Rex.